Hey everybody, Dr. A here, and in this video we're going to be exploring another applications of material properties example. So let's dive into it. In the given information, we're being asked to determine the Euler buckling force that will cause the column to buckle. So here we have this column, and we see that it's pin connected at its ends, and it's 15 feet long. We're given a moment of inertia of 150 inches to the fourth power, and a modulus of elasticity of 29,000 kips per square inch. That's what a KSI is. So if we recall from our background video, the Euler critical buckling formula that we were given is PE equals pi squared EI over KL squared. Now, for a pin-pin case, K equals 1, right? Pin case. And remember, in real life, a column might not be pinned at its ends. It might have different kinds of restraints here, but for the purposes of this introductory material, we're going to say we've got a pin case, okay? So if I scroll over, I'm going to say that Euler equation, PE equation, becomes pi squared EI over L squared, okay? And here I can just substitute values in. Pi squared times 29,000 kips per square inch times 150 inches to the fourth. Now, what about, draw that division bar a little bit better. What about L? Well, L down here is 15 feet, right? It's 15 feet, but you have to be careful with your units. Notice I is given in inches to the fourth and E is kips per square inch. So we need to convert 15 feet to inches so we have consistent units. So 15 feet turns out to be the same as 180 inches. And I know that by just saying 15 feet times 12 inches per foot, okay? And so here I'm going to say this is 180 inches, and I'm going to square that, okay? And so I'm going to punch this in really carefully in my calculator. Punch it in twice if you need to, but you've got pi, which is, 3.14159, etc. Square pi, okay? And then you say times 29,000 times 150 inches to the fourth, and then divide by 180. And so what I end up getting is a rather large number, okay? Don't forget to square that 180. I get a rather large number. I get 1,324 kips, okay? And so what that means is this is the force that will cause the column to buckle, okay? So if we were to draw this out, what that would look like is, here's my column, okay? Here's my column. It's pin connected. My battery for this is always going low. There's that 15-foot length, and that P Euler, that is the load, PE, that will cause this column to tend to buckle or bow out like that, okay? So that's what that means. Now, if you want to check your units, again, you should end up, it's a force, right? So you should end up with units of force, in this case, kips. How can I check that? Well, here we go. Let's do a unit check here. I've got inches squared down here in this denominator of the KSI, and that's going to cancel with 2 of the inches here. So that 150 that has inches to the fourth, it's going to cancel with 2 of those, and you're left with inches squared. Well, then in this denominator, you're squaring length, right? So that means that this squared goes to this inches. You get inches squared. And so finally, you'll have inches squared canceling with inches squared, and what are you left with? Just kips, okay? So that concludes this example. If you found this helpful, please hit like and subscribe, and be on the lookout for other content like this. Thanks for watching.